He reminded me to record. You did or he did? Okay, so please write down finding measures of arcs. There's quite a few. I'm just going to call them baby vocabulary. There is some vocabulary that's going to happen here. Wait, is it on the next screen? Oh, yeah, it is. Okay. Please do not draw these. I don't expect you to draw them. But we're going to talk for a minute just about circles and pieces of circles. And I feel like we've seen stuff like this. If you look at, this is the number of people who like Lucky Charms. This is the number of people who like Cheerios, right? And they're represented as percentages. So CJ, what are all the percentages going to be together? 100. And I don't know why we know that, but we just know that. The whole thing is 100% of the people surveyed. Okay, so Delta, how could I find X? Yeah, so 100 minus 23 minus 14 minus 43.
So technically, that completely throw in the corner. This is about 25%.
Maybe, yeah. All right, Lindy, looking at this circle on number 2, it's not percentages, it's a degree. So what do we know about the degrees of a circle? Someone said it. What is it? Okay, if you don't know that a whole entire circle from one edge to the other is 360 degrees, draw yourself a circle and write that. And we use this in the Olympics. If you are a skateboarder or a skier, they'll say like, oh, I landed that 360. It just comes from circles. But a lot of people have heard that, so this number kind of sticks out to them. If I look at y, does anybody know what that is called? Half of a circle. Does anyone know the other term? It's 180. We know lots of things. This is 180. It's created by a diameter. And we call it a semicircle. So again, if you don't know these are little, I call these baby vocabulary words because we kind of know it somehow. Olympics or skiing or whatever, somehow we know these numbers. So if I've got a diameter all the way around, semicircle, 180 degrees. So Emery, how could I find x degrees on number 2? Well, what do we know about 61 plus x? What would it have to equal? Yes, if this is half of a circle, this is the other half. What's another way we could find it? Yes, so in my mind, there's 2 ways. Some students are going to say 360 minus the semicircle, the 180, minus 61. Or others will notice if this is a half of a circle, so is this. And it's a little bit shorter, 180 minus the 61. Okay, enough with that one. Yeah?
Is there a way to show that that is like an actual semicircle and not like 170 degrees? Like, you know how 90 degrees has like something that we know is...
No. Because if you look over here, this is not a diameter, but I don't know, like, oh, wow. I'm not sure. My sleeves keep touching the board. Why did you stay down there? I don't know if you can tell from further back, but this is kind of bent. I don't know. I hope so. I hope it's obvious. Yes? Yeah, especially if they give you a lot of the pieces. Yeah. Hopefully they'll just tell you that it's a diameter. I don't know. There is one problem on the homework, though, and this kid is like, they didn't tell me it was diameters. I wasn't 100% certain. So, okay, let's look at this number 3. We've got a couple pieces that are x's. Miles, how might we try to find these, what x is? Oh, I like that. So 360 minus this, minus this, minus this. I probably shouldn't cross them off. Okay, and then whatever I have left, what would I do with that number? Divide it by 2. I don't really care right now what they are. I just want us to explore and get thinking about semicircles, complete circles. This is kind of like angle addition. We were adding them up and subtracting them from a whole. Okay. In your notes, I'm going to draw this exact same thing but kind of bigger. So draw yourself a circle. These are 2 of the important vocabulary words that we're using today. There's a lot of different angles that happen in a circle. So this one has the center labeled as C, and then they've got these radius that goes to A and one that goes to B, and then they have a random floating dot over here that's D. I want all of those things on your drawing. Smart. So make your center a C, come out from the Pac-Man mouth, and it's going to be A and B, and then randomly floating over here is points D. That's important. What this creates, it's taking that whole outside of the circle and it's breaking it up into pieces. If your piece is less than 180 degrees, and I'm talking about from here to here, it's called a minor arc. The measure of a minor arc, and I'm not talking about the length of the arc, which was very confusing to me. I'm not taking a tape measure and measuring like 1 inch, 2 inches, 3 inches, 4 inches, 5 inches. That's the length. Part of the circumference would be the length. This is the measure, and it reflects exactly the measure of the central angle. So the measure of a minor arc reflects the measure of the central angle. So the measure of a minor arc reflects, so it's not a length, it reflects the measure of the central angle. So 2 arcs can have the same measure, but not be congruent. Can you see that? Like I could draw a smaller circle that has the same measure of an angle, but the arc would be shorter, which is, it'll come up in a minute. My brain does not like that part. All right, I hate when there's a vocabulary word within a definition. I don't think we've ever talked about what a central angle is. So Sarah, in your opinion, what's the root of that word central angle?
Like the angle that comes off from like the
That's exactly what it is. So that's why I keep calling them, you look really pretty today. That's why I keep calling them baby vocabulary words, is because you can kind of logically think through it. A central angle, its vertex is the center of the circle, which is different than an inscribed angle, which we'll do later. So make sure you try to say these vocabulary words. Okay, so what that's saying you can see on this picture, I didn't leave much room on mine. If this is a 50-degree central angle, the measure of this arc, it would be 50 degrees, not the length, but the measure. Yes, which I hate a lot, but okay. We write it like this: the measure of arc AB. In order to know this is an arc and not a chord or not a secant, is you put like an arc on top of it. So that's the minor arc. And we name it with 2 letters. I think most of the time it's 2 letters. Okay, the next part, and again, I don't know why it's here and then I'm just writing it again. I just feel like I need to. We know that the measure of the whole circle is 360, so hopefully you wrote that down if that's not something in your brain. So the major arc major arcs are bigger than 180. Minor arcs are less than 180 degrees. Major just meaning it's big. Minor meaning it's small. And we label these by using 3 letters because can you see, what color did I make it? Green? Let's make it blue. If I want to do the major arc and I want to start at A, and I want you to end with B, but I want you to go this way, the way that I tell you that is I give you a 3rd letter, this D. So that one is the measure, and you say A, D, B. You have an arc over it, but that's going to tell me I have to pass through D to get to B. There's 2 choices, and that's how they'll let you know. This is going to be the major arc. It's bigger than 180. You have to go the long way around. Luke, how would you find the measure of that major arc A, D, B? Yes, so you can take the 360, which is the whole, and subtract the minor arc. Hey, look, it's up here in another color. I just feel like you can see it better. All right, so lots of vocabulary. A minor arc is less than 180, and it has 2 letters to name it. A major arc is the long way around. It's 3 letters, greater than 180 degrees. And a central angle, the vertex is the center of the circle, like Sarah pointed out. Raise your hand if you need me to stay on this slide for longer.
It's right on 180, then what is it called?
Oh, yeah. Semicircle. If it's right on 180, I'm glad you said that. If it's right at 180, it's not major arc, it's not a minor arc, it's a semicircle. I don't know if you say it's semicircle or semicircle. Semi-annual? Why is that semi? I don't know. I've heard it said both ways. Okay, let's look at this. I don't know that I'd expect you to write this down, but I do want you to be finding out the answers, so when I call on you, you can answer. So everyone look up here. I want you to look at the picture and picture where RS is. Arc, RS, because it's got this arc on top of it. So Emery, what is the measure of arc RS? Yes. Ooh, wait, does this one say Y? Oh, no, you don't have to say Y. Oh, I do like that it says that R to T is the diameter. It's really nice when they tell us. Okay, Porter, what is the measure of arc R, T, S? And you can take a minute because this requires a little bit of math. Everyone else be calculating, thinking, calculator-ing. And how did you find that? Yeah, we know that the whole circle is 360. We don't know much else, but we do know that this 110 is not a part of it. Okay, Grace, is RTS, is that a major arc or a minor arc? And why? What makes it so major? Bigger than 180. Okay, last one on this one. Angle R through S all the way to T. Let me see, what's the degree of that arc? 180. And how did you know that? Yeah, it told me it was a diameter, so I know it's a semi or a semicircle. All right, very good. We use this, I think, once on the homework, so I will mention it. If you are given, like, let's say I tell you from A, B, C, let's say it's 270 degrees. I have no idea what it is. And then I give you, like, equations like x and 3x minus 5. How could I find the measure of these arcs? Yeah, you can use this arc addition postulate. This is not on our formula sheet, but it just says that this one plus this one will equal the whole thing, which they would have to give you all 3 of those pieces of information. Do you guys feel like you need to write that down? Okay, if you get stuck on that question during homework, just raise your hand. I think we're good. I still think we're good. Let's do a little bit more practice on this. We have a lot of time still. Okay, I'm only going to ask 3 of these. And where did I kind of get to? I feel like I skipped the whole middle row. I'm too Zara. Okay. Okay, Zara, arc T, Q. What's the measure? Yes, minor arc because it's 120. No. Addie. Wow, you guys, sometimes that just happens. Q, R, T. First of all, how do I know to go that way? Yes, if there are 3 letters, you have to pass through the middle one before you can get to the third one. Earlier, I don't know, how did kids mess this up? They went Q, QRT, and they told me it was 180 degrees. Did everyone watch it? Because like 5 kids did that last class period. So if we're talking about arcs, you don't just get a dart through the middle. You have to pass through and continue on the, you have to continue through. Like you all are like, oh, I would have done that. Do some of you think that? So let me show you again what not to do. It doesn't mean Q, R, semicircle. Absolutely not. These are all just arcs. Q, pass through R, and head to T. Okay. Addie. Yeah, give me the measure of the major arc. Just a second. You're fine. The rest of you be thinking, how would you find that major arc? She's going to do it for us. There's an easy way and there's a hard way. I think she's going the hard way. Which is okay. How did you find it?
I subtracted the 68, 80, and 120 from 360.
And what did you get? Yeah. Okay, so this is what she did. She found this is 100. She did 360 minus the ones that she knew. Okay, and then what?
And then you just add the 80, 100.
Then we can add these 3 that make up the major arc. And what did you get? Paige, what were you going to say? No, I've never seen that. 2 letters for a minor arc, 3 letters for a major arc is all I've seen so far. Yes. And you have to go the long way. Go Q past S to T. Yes. So sometimes it has you passing over a letter that they don't mention. Is that kind of what you're saying? Okay, does anyone know the short way to find this answer? Tate. So how would you have found it? So we don't really need to know this bottom angle to find the missing one because we know that the whole thing minus 120 will give us the part that we're talking about. But both ways work. And once you have the 100, it actually makes some of these other ones easier. Like if I go from Q to S, so it must be a minor arc, right? If it goes from Q to S, if it's a major arc, it would have to tell me to go the major way. If it's a minor arc, I can head the shortest route. So since she has the 100, now I can just add those 2 together. Yes? Minor arc. I don't know that I've seen that on the homework, but on this example, it does show that. Okay. In your notes, will you write congruent circles theorem? It's not on your theorems paper for some reason. Actually, I better make sure it's not on there, just like out of order. So put this in your notes. Or you can put it down here in this space, because it is a theorem. Like on the back. I just feel like it should be on the theorems page. Two circles are congruent. What does the word congruent mean? The same measure in a different location. So two circles are the same circle in a different location. That's what it's saying. If and only if they have the same radius. So I'll give you a minute to write that. Again, I think I would put it on the back of my theorem sheet where there's a little space because it says it's a theorem, but there's not a spot there.
It's either being me or Luke or me.
They are not the only ones on the planet. This seems like a baby theorem to me also. Oh, so you're telling me that if I have two circles that are the same, they're the same? Yes. That's what I'm saying. Yes. Yeah, it does say the same. It doesn't say a part of this, but two radius and the diameter are they're cousins. So the one thing I want to remind you, I remember thinking this was so weird in high school. This statement that says if and only if, think of it like those revolving doors. Okay? So you can say this frontwards or backwards. You can say if two circles are congruent, then they have the same radius. Or you can read it from the bottom up. If two circles have the same radius, then they are congruent. It goes either way. So you can prove it front, or you can use that proof backwards. Okay, here's the one that's actually going to be on the paper. And I will pause for as long as we need to write this down. It's your third box. It's your third box down on the front. And I do want you to write the words. You can use this symbol instead of writing the word congruent. You can come up with like if and only if. Like you can come up with shortcuts. These are your notes. But I do want you to write it down with the picture. Congruent central angles. We know what those are now. We know what congruent is. They're the same measure in a different location. So in the same circle or congruent circles, which is the same circle in a different location, two minor arcs are congruent if and only if their corresponding central angles are congruent. This part's going to be important in a minute. In the same circle or in congruent circles, that has to be there. Two minor arcs are congruent if and only if. Is that a good size for the? Mm-hmm. If and only if their corresponding central angles are congruent. And then the picture has two diameters kind of coming through here that create two minor arcs. And then as you come into their corresponding central angles, they're going to be, their vertical angles, they're going to be congruent. Oh, interesting. Okay, if you haven't had time to write this whole thing and draw the whole picture, I will come right back to it. But we're going to do some examples, and then I will leave this on the screen when you go to do your homework. Okay. I want you guys to look at example A, B, and C. So no one say the answer out loud, but I want us to look at this picture on A, and I want you to think in your head, are the red arcs congruent? And explain why or why not. So I want all of you to be ready to do that. Jose, what do you think? Are those red arcs congruent, and why or why not? Oh, I don't know.
Yeah.
Why? Yes, how did you know the arcs were 80? It gave me the central angles, right? So our theorem just said, we're on the same circle. That was really important. If you're on the same circle or a congruent circle, check. And the central angles are congruent, then the arcs are congruent. So it met all three of those things. Okay, look at B. Are the red arcs congruent? Explain why or why not. I want you guys to all think and come up with your own answer. Do you think they are congruent? This is the fun part. This is the part of the lesson that I don't like. Okay, Lauren. Okay, so we feel like because of that theorem, because they have the same central angle, 90, so the measure of this is the measure of 90, and the measure of this is also 90 degrees. Are those pieces congruent?
No,
Why?
because we're small.
Okay, so the part that we want to, the part that gets confusing here is these are two different circles. I know they're sharing that center Q, but this one looks to have a radius, I'm just going to call it 2, and this one looks to have a radius of 3. So the very first part, in the same circle, are these the same circle? Are they congruent circles? Because congruent circles have the same radius. No. So this is confusing to me. Both of the arcs are called 90 degrees, but they are not congruent. Yeah. So the measure of both of these arcs, the measure of arc RS is 90, and the measure of arc TU is 90. But the word congruent means that they're the same measure in a different location, the same length. This is where I think I use that word funny. This is clearly smaller, like it would maybe get me to there. So the answer is no. The arcs are not congruent because the circles are not congruent. They're the same measure. They are the same measure, but they are not congruent pieces. I hate it myself, I know. Okay, C. Look at C. Are the red arcs congruent?
Yes.
Oh, you're not supposed to say that. Zara? Why?
Because the two radii are congruent with the little line, and they both have the same 95 degrees. Central angle.
Why did they have to tell us that?
Well, because
Yes. So 2 slides ago, we talked about congruent circles have the same radius. So this is telling me these are the same circle in a different location. And then yes. Okay. 2 more. Don't yell the answer out. Number 7, I'll call on somebody. Tell whether the red arcs are congruent and explain to us why or why not. So everyone think of their answer. Tristan, what do you think? Why? Yes. The circles are congruent. The central angles are congruent, so their corresponding arcs are congruent. Okay, number 8. Tell whether the red arcs are congruent. Explain why or not. Tyler, are those red arcs congruent on number 8? Why? Yes, so these circles are not congruent. The measure of the arcs is the same, but the arcs are not congruent. Does that bother anybody else? Yeah. So the measure of the arcs it equals 120, and the measure of arc PQ is 120. But arc MN is not congruent to arc PQ because they're not the congruent circles. They're not the same circle or the congruent circles. And remember, congruent circles mean that they have the same radius. Okay. That's it. Big ideas. You have 20 plus minutes. If you haven't finished yesterday's because you have like 1 or 2 left, finish that up.